companies that design plastic parts or injection molds, SolidWorks Plastics software helps users predict and avoid manufacturing defects during the earliest stages of part and mold design, eliminating costly mold rework, improving part quality, and decreasing time to market. Fully embedded inside of SolidWorks with intuitive workflows, SolidWorks Plastics allows you to choose a material from a database containing thousands of the most commonly used plastics. Once you've selected the material, you can then specify various processing parameters, such as injection molding machine size, melt temperature, mold temperature, and injection time. Of course, you can also accept intelligent default values for any of these. The next step is to choose an injection location and run an analysis to determine whether or not your part will fill with melted plastic and if there are going to be any manufacturing defects. Being able to predict and eliminate those defects and avoid costly mold rework is what makes SolidWorks Plastics so valuable. In this particular case, the part does not completely fill. It's what we call a short shot. SolidWorks Plastics generates a number of result plots, including fill time, pressure distributions, and temperature distributions that we can look at to determine the cause of the problem and identify potential solutions. And by animating the fill time plot, it's easy to see that the melted plastic does not reach the edges of the part cavity. Here, we've determined that the part wall thickness might be too thin, so we're going to increase the wall thickness, run another simulation, and see what happens. Of course, changing the part wall thickness is quick and easy because you can use the same SolidWorks features and functionality that are part of your day-to-day workflows. You can now see that the part fills completely, and the fill time animation shows you exactly how this part will fill. This animation also provides insight as to where weld lines and air traps will form and if there will be potential cosmetic or structural problems. We can now move on to designing and analyzing the family mold layout that will be used to produce this part along with its mating component. When manufacturing mating plastic parts, as seen here, it's common practice to mold both parts in the same mold so that they have the same molded part properties, such as mechanical strength, surface appearance, optical properties, and chemical resistance. However, an additional challenge is introduced because when you mold two or more parts of differing geometry in the same mold, your goal is to get all the mold cavities to fill at the same time. And this can be virtually impossible to achieve without the use of SolidWorks Plastics simulation. The good news is that you can perform a runner balancing analysis in SolidWorks Plastics. This is a multi-iterative analysis with the objective of filling multiple cavities of differing geometry at the same time. As the iterations progress, the runner dimensions are changed to achieve balanced filling. And once SolidWorks Plastics converges on a solution, it will indicate the final runner dimensions required to achieve balanced filling, resulting in mold cavities that fill at the same time and with uniform pressure distributions, minimizing the risk of post-molding defects such as part warpage. With SolidWorks Plastics, you can predict and avoid manufacturing defects during the earliest stages of part and mold design, eliminating costly mold rework, improving part quality, and decreasing time to market. This has been your first look at SolidWorks Plastics. To learn more, contact your local SolidWorks reseller or explore our website for more information.